Welcome everyone. In this video lecture, we will draw the layout design of a two input NAND gate which is based on the CMOS structure. That is our some PMOS and NMOS. So I have already draw the two input NAND gate, okay, in which two NMOS are there, M1 and M2, and two PMOS and 3 M4 are there, and we are taking output across this it. Okay. So first of all, I have already discussed in my earlier video how to draw all these things. So I am not discussing that part. So our major focus is on to draw the layout design. So before that, what we have to do? First of all, we have to identify the terminals in. Okay, in any CMOS structure, first we have to identify the terminal. Why? It will clear after some time. So this in, suppose this in is a source terminal of S3. That is our S3. Arrow sign always signify the source terminal. So that's why I'm always putting arrow. Okay. This will be our source of 4 terminal, and this in is our gate of 4. This in. Okay. And this in is, we can say, gate of 3 terminal, and this in is our what, drain of 3 or drain of 4 terminal. Okay, I have written the terminal only. First try to write the terminal. Okay, and this one is the drain of M1. Okay, this in is a drain of M1, this one is our gate of 1, and this one arrow sign is always source terminal, source of 1. Now again, this one is our drain of 2 terminal, gate of 2, and this one is a source of 2 terminal. So this one we have written. Okay, very simple. Okay, means gate, source, and then we have to write in any circuitry. Okay, then after there are two PMOS, two NMOS. So first of all, we will make the PMOS. So the for the PMOS, what we will do, we have to make a anvil. Okay, so for that purpose, I am anvil. Okay, inside that we are taking an active area, or we can say the P plus diffusion, which is of yellow color. In stick diagram we are using yellow color, so I am also using the yellow color. Okay, and then after there are two get terminal, so there will be a poly line. Okay, polysilicon line. So one line will be like this. Just I am making the transistor. Okay, clear. So now we have to think which one is, basically this one we are making for the PMOS. Okay, so we can also write this one is our, or here I am writing N well region, and this yellow one I am writing with some active area, and this red one is our polysilicon line. At the end we will make the final one, but first we have to identify how to draw the transistor polysilicon. These two are the polysilicon line. Okay, so one more thing, that so this one I am saying this one for the M3 transistor, okay, and M4. Okay, and this polysilicon one will give the gate terminal. So we can say this one is our VA. We can give the input VA here and VB here, M4 transistor. Okay, and this one is nothing but simply we can say the gate of 3 terminal, and we can say the gate of 4 terminal. Okay, now we have to identify which one is our source and drain. Okay, so here we can say this side we can make it source. So if I am making it source, S3 terminal, this will be automatically, we can say this one is our drain of 3, drain of 3. Okay, drain of 3 terminal. Now This drain and this drain is connected. So this end will be also drain of water. Okay. And this side is our source of 4. So now this one is clear because in the stick diagram, what I am saying, the people's diffusion, and if there is our, or say this one is our, okay, first take the yellow line. So P plus diffusion is there and red line is there. So this red one is our gate always, and this will be either source, okay, source or drain or source. So this one is gate. So either this side will be source or drain. So I am taking this as a source, so this side will be drain. Now this drain and this drain is connected. So drain 4, drain 3 connected, and M4 is the polysilicon that to transistor, M4 transistor. So source will be like this. So this one is the PMOS. Okay, now at the end we will add the VDD. Okay, so we can make some arrangement. So first we have to focus on this one, how to make the PMOS. Okay, this one is our, we have formed two PMOS, which is our M3 and M4. Okay, this one is a M3 M4. Okay, at the end we will make the final layout. Okay, now similarly we have to make two NMOS. Okay, so what we will do for NMOS, the active area or N plus diffusion is of green color line. Okay, select the rectangle. Stick diagram I have also covered, you can follow. Okay, for that I'm saying this one, active area. Okay, and then after we are taking two polysilicon line like this, because two NMOS is there, so you just make like this. Okay, then after we can easily say this one I'm saying M3 having input VA and M1 having input VA. So at the end we will club. So I am just writing this transistor H M1 and this one is our M2. And here I am writing this one is our VA. Input we will give to this polysilicon line VA at the gate 1 terminal. So I am writing like this. And M2 we are giving the VB. Okay na? So VB with gate of 2 terminal. Okay, now at the end we will club it. Okay, but first we have to make it separately. Okay, if you will expert, you can directly make all these things. Then after M1. Okay, now what we can see here, drain of 3, drain of 4 is there. Okay, now drain, this one is drain. So and this source and drain are connected together. Okay, so what I am writing, if I am saying this one is the M1 transistor, so make this as a D1. Okay, anything you can make D1. Okay, so this one is gate, so this should be source of 1. Now this source of 1, and if this one is source and drain of 2 is connected, so you can write like S1 D2. Okay, clear this one, and then it should be D2, so it should be S2. Okay, clear. If you write here S1, there should be D1. Okay, and D1. Okay, so and S1 and D2 is connected. That's why we have made this kind of arrangement like this. S1 D2 is common in this side, so that's why we have put a D1 here. Okay, so now this one for the M1 transistor, M2 transistor. Now we have formed the all the M1 M2 transistor. Now the supply is in the source of S2, that we will make it later. So this one is the two NMOS that we have made. Two NMOS, that is our M1 and M2. Why we have made this as a common? Because S1 and D2 is common. So that's why I am taking this side as a D1 and this side is S2, S1 and D2. Here D3, D4 is common. Okay, so in between we have to make clear. So this is the arrangement for the all NMOS and PMOS. Now we have to club it together with, and we have to add the output port, input one we have already added, and ground and all. So now we will go for the final combination. Okay, now how we will combine. So first of all, I'm just drawing the same diagram. Okay, take the output. Say this one is the output. Now how we will draw this one again. So first, what we have to do? First, make the PMOS. Okay, so for PMOS, okay, okay, and then I am also making a active area inside this. Okay, then after one more for the NMOS, N plus diffusion. So a rectangular block having green color, then polysilicon line for the gate terminal we have to make, or make it here. Okay, now we have already discussed that this polysilicon is our VA, and this one is our, we have already made this as a M3 transistor, M3, M4, and this one is our M1, M2. Okay, because M3 and M1 having the same input VA, and both inputs are connected. We can say this one is connected. Okay, having input VA. So that is why we are writing like this. So this one is VA. Okay, or gate terminal is there having the gate 1 and gate 3. Similarly here what we can say, this one is our VB having gate of 2 and gate of 4. Okay, now this side I am taking this as a source. Okay, once again I am writing here, I am writing source of 3. Okay, so it should be our drain terminal, drain of 3, drain of 3, and this one will be our what? Drain of 3. This one is drain of 3 na. Once again, this one is our drain of 3, drain of 4. So this one will be our drain of 4 connected together. This one is our source. Okay, S3, S4, gate 1 is okay. So D3, D4. Now it is connected to the D1. Okay, so D4 is there. So PMOS, it should be our S4. Okay, now S3 and S4 is connected to what? VDD. So for VDD, what we can do? We have to, and then we have to make it like this. And we have to make the contact. Okay, so means S3 and S4 is connected to VDD. So that's why we have, and this one is our VDD line. Okay, so this part is over. Okay, now we have to take the output between D3, D4 and D1. So now S1 is there. Sorry, M1 is there, D1 is there. Okay, you can also write the all this gate of 1, and this one is our source of 1, and this one is our drain of 2, and this one is our source of 2, gate of 2. Now source and drain is connected. Okay, source and drain is connected here. Source and drain. So we can write like this: S1 and D2 will be in this side, and D1 will be like this side, D1. Okay, because source 1 and D2 drain of second NMOS 2 is connected. So I am writing like this, and it should be our S2. Okay, so now what we will see, we have to take the output from these two sides. Okay, okay, I'm taking this side and drain. Okay, 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 we will- okay. So what I am doing, I will tell what I'm doing. Okay, very simple. Means this one, drain of 3 and drain of 4 is connected together. Okay, so make the connection, okay, contact between this drain and then this drain one. Okay, means this drain 1 and drain 3, drain 4 are connected together, and we are taking output from this side. So we can write like this is a V output. Is it okay? Very simple. V output. Clear? Means D3, D4 and D1 is connected. D3, D4 and D1. That's why we are making like this. Okay. Now next, output is over. Input is also over. VAB we are giving to this polysilicon line, and the source of S2 is connected to ground. Okay, so source of H2 is connected to ground. Okay, so I'm just taking this one here, source of H2 is connected to ground. So make a contact. This will be our ground. Okay, source of H2 is connected to ground. We are taking the output from this, and this is our what we can say, if you can make it hash line. Okay, polysilicon line, I have the gate terminal. Okay, where G3 and G1 is connected together. Okay, so this is the layout diagram of a two input NAND gate. Okay, so this is the way how to just draw. Okay, but in more accurate way, you can also very precisely we have to make this width and all, but this is also okay for the academic purpose. So this is the all about the two input NAND gate layout design. Okay, which is based on the CMOS circuitry. This CMOS circuitry. So very first thing is to identify the all source drain terminal, the gate terminal, and then first make this one. If you are able to know this how we are making, then finally you can club it together and you can make VDD and all. This is all about this video lecture. So thank you for watching this video. Thank you.